It'll be located in Canvas. It's not there now because you're not taking it right now. So when you take it, yes. Yeah, so I don't think there's anything else. Oh, I was going to talk about Up All Night. So I posted something about Up All Night. Does everybody know what Up All Night is?
No, but I saw your announcement about it or your email.
Is it self-explanatory?
I'm not sure if it's self-explanatory. What it is it's going to be basically some tutoring that's available for this class to help study for the final. It's on Wednesday, April 29th. I didn't see anywhere that it says that we're going to do a review. Have you heard anything, Jordan, about a review session where you actually do like a little lecture? Or Leon or Robert, has anybody heard anything?
I haven't heard anything.
Okay, I'll find out from Brittany because I saw that the tutor were listed under tutoring, but I didn't see that we were listed under review.
I think what might be best because she wants 2 people doing it at the same time.
Yeah, we already have that. Jordan, I'm not sorry, Sydney and Leon are going to be doing it.
I thought it was going to be me and Josh.
No, I guess Jordan. I mean, I guess Leon and Sydney already answered, and so you didn't.
Oh, okay, all right.
Because I think she sent out an email. Is that correct, Leon?
She did, but you brought it up during. You brought it up during the office hours, so I thought it was going to work the same way as last time, which was you just told her.
Oh, okay. For the review. I'm going to find out if there's going to be a review. I don't know at the moment. Let me write myself a note.
I was just going to say for Up All Night, the smartest thing I think to be done would be just if we have, because you can't, if you have 2 LAs in the same section, you're either going to be putting them into break rooms or you're going to.
No, it's going to be there's an Up All Night web.
Oh, in person?
It's a whole, no. There's a separate, it won't go through my class. There's a separate link to a separate WebEx.
Yeah, no, so that's why I was saying I feel like if we have 2 people working and if it's just supposed to be answering questions, from all the experience I had at Up All Night, that many people don't come, so I thought it would be best if you had one tutor actually just having like a review session and the other tutor answering like small questions for people. Because that's what I was going to talk to Josh about, but since it's Sydney and Leon, I'll just, they could do them.
Okay, let me talk to Brittany and see what she says. I'll talk to her about all the things that you just said, and let me see what she says.
All right.
Usually we have both. Usually we have a review session and a tutoring session. They're at different times, but I don't know why we're not listed under the review session. So let me find out. I'll get back to you, Jordan.
Okay.
Okay, thank you. So is that clear about what Up All Night is, guys?
Yes.
Okay, good. More or less. Do you have a I'm sorry, Chris, do you have a question? Okay. If you have any questions about anything, just let me know. So that being said, should I just begin?
I do have one question.
Yes, sir.
Do we have to let you know before Monday which exam we're taking? Or is it
no?
It'll
just show up. What I'll do is I'll open all the tests. They'll all have the same password. You go into whichever test you want to go into, and that'll be your test. If I catch anybody doing more than one makeup test, I'll just give zeros for both of them. So.
Do I have still time to turn in all my missing work?
No. What missing work? You mean from Alex or from missing work?
Missing work.
No, only Alex. Alex opens. You can turn in all that. You can keep working on Alex until the day of the final. As far as any missing homework or LA worksheets, no, I don't have anyone to grade a whole semester's worth of missing work from however many people there are. So that won't happen.
If we notice that some of our work that we did turn in is showing up missing on our Canvas grades, should we discuss that with you now, or should we wait after the final?
I wouldn't wait till after the final, and I don't. What we can do, Venica, is we can talk about it today, but let's not talk about it till like later. Okay.
Okay.
Ms. Greenberg,
Yes.
know if the summer courses are still supposed to start at the same time that they were originally supposed to?
All the summer courses are doing exactly the same thing. They're all online.
Yeah, but they're still like starting the same day, like the
Yes.
original dates that FAU said.
Yeah, everything's the same except it's online instead of in person. Yes.
Okay.
Okay. Chris, I'm not sure I understand your question. Are the types of tests listed, topics, lessons, etc.? I don't know what that means. I want to answer it, but I don't understand the question. Go ahead, Joe. You have a question?
No, I'm good.
Oh, okay.
Let me mute myself.
I'm just waiting. Chris is typing, so I'm just waiting to see if he types me something. Hold on. Okay, I don't see anything, so let's continue on. All right, so I'm going to start the lecture unless, oh wait, I think we got it. Oh, so the final you're talking about, Chris? Or are you talking about I'm not sure what test you're talking about. Oh, yeah, so the test retake any test, just look at the 4 tests that you've taken, and you can retake any one of those 4. Okay, that's it. You can retake any one of the first 4 tests, first 4 tests. Okay, perfect. Also, let me just tell you, because I told the early class, let me tell you, and I'll probably post an announcement about this at some point, but for the final exam, there will be a paper portion and an ALEKS portion. The paper portion will be only limits, derivatives, and integrals. The ALEKS portion will be anything we covered the whole semester that was in ALEKS. So I'm not going to go back over and retest you, because I want to be able to test you on the limits and integrals and the limits. And I think I said limits twice. Derivatives, limits, and integrals. And there's not that many problems in ALEKS. So, and there's none for derivatives or integrals. So that's what the paper portion will be. Okay? Everybody got that? That's a yes. All right, let's start the lecture. Yep, okay. All right, let's start the lecture. So today we're going to start talking about derivatives. And so let me talk about what is a tangent, because it's very important to know what a tangent is, because derivatives actually are the slope of tangent lines. And we'll get to that in a little bit. But let me just say, if I have a graph, let's say I have a graph that looks like this, and I want to know what the tangent to that point is. The tangent line, is the line that passes through a point on a curve at exactly one point. That's supposed to be, let me see if I can move it a little and make it a little better. So it just touches the graph at one point. Okay? So notice if I did that perfectly, it would there's not 2 points touching the original graph. This is a tangent line. I'm sorry, Chris. I don't know what you just typed. Can you do it again?
Question.
Yeah, Joey.
Does the tangent line have to be the same slope, or does it?
The same slope is what?
Like, can it be any slope?
Well, it has to
As
touch in exactly one point. So it can't, if it touched in, like, let's say I want a tangent here, well, that would be like that, right? But if I turned it just a little bit, notice it's touching in more than one point now.
Okay, that's what I was wondering.
So the apex of the curve, correct? So it's not about the apex, it's just a line that touches a graph at exactly one point. So like, let's say I have, I'm sorry, 1 second. Let's say I have a circle that touches in one point, right? Any other, if I do any other place, as long as it would touch at 2 points, right? So this is the tangent, the one that touches the graph at exactly 1 point. No, it doesn't have to be the max or min. It could be anywhere. Is this point right here the max or the min? What happened? Okay. I don't know where my graph went, but let me put it back in. So is this point right here that I'm coloring, is that the max or the min? So it's not, but I can still make a line tangent to the curve at that point. That line, if I was perfect at drawing this, it would only be touching the graph at 1 point. Is that clear yet? It's not about what the curve looks like. It could be a circle. It could be anything. So it doesn't have to do, it just touches the graph at 1 point. Go ahead. I think there was another person talking.
So it can't cross it. So say, because on this, like S curve that you have, say it were to cross diagonally, it would still touch the graph at 1 point.
Can you draw what you're talking about on the graph?
Let me see if I can.
Let me see. I might have to give you some kind of permission. Okay, yes, approve. Oh, I see. Oh, that's cool. I have to approve you, but then go ahead.
Okay, so say that this is my point right here. Oh, I'm purple. Okay.
Okay, I see it.
Could a tangent line go this way? Because it's only, that's such a bad...
Oh, I understand. No.
No? Okay, so it can only... Okay.
It has to, like, follow the line. So, the curve.
Oh.
So, it would be more like this.
Okay. Thank you.
Of course. That was a great question. I didn't realize what you were saying. Perfect. All right. So, does everybody understand now what the tangent is?
Mm-hmm.
Yes? Okay, good. Now, that is the tangent line, and that crosses at 1 point. We also have something, and it doesn't have anything to do with the tangent from trim, by the way. It's not the same. Because I have another line here. Notice I have another line here, and we call this the secant line, and it basically connects 2 points on a curve. Okay. So it's just terminology. So if now that we have an understanding about what those words mean, we can move on as long as we have that understanding. So here's a curve. Let's say I have x squared. So here's x squared, right? And what this is doing, here's a point 1, 1. Here's my point 1, 1. What we're doing is drawing a box around this point. And we're saying that's what that first picture looks like. It's curved. But if I zoom out more, or if I take a smaller piece of it, it's going to look a little less curved because I'm getting a smaller part of it, aren't I? And if I get even a smaller part, it almost looks like a straight line, doesn't it?
Yeah.
Okay, good. So Now, why do we care about all that? Well, it has to do with derivatives, okay? So I'm going to move this up, and I'm going to... So I'm going to read you the definition of what the derivative is, and then I'm going to explain what it means, so don't panic. So the derivative of a function f of x with respect to x. So this is a function y where x is my independent variable. And this is notation for derivative where it says f, we call that f prime. I'll show you some more notations in a minute, but that's f prime. And that's the formula for the derivative as long as the limit exists. Now, let's see what that means. Let's say I have a graph, and the derivative, let me just write, the derivative is the slope of the line tangent to a curve at a point. Okay? So does that make sense? If I draw a curve and I make a tangent line, the derivative will give me the slope of that line. So let's say, for example, I have this graph and I want to know what the derivative, I want to know what the slope of the tangent line at that point is. Okay?
Okay.
Y'all following so far, right?
Mm-hmm.
Okay, so how do I find the slope? Well, if I want to find the slope of a line, it's equal to y2 minus y1 over x2 minus x1, right?
Yes.
But I only have one point. And if I make the points the same, I'll have 0 over 0. So that's not going to work. Does that make sense?
Yes.
Okay, so we can't just find the slope of a tangent line very easily. So what we do is we say, okay, I'm going to call this point x, and I'm going to call this f of x. So I know that the coordinates for that point are f comma f of x. And what I'm going to also do is I'm going to pick another point on this curve, let's call it, and I'm going to call it x plus h, where it's x plus some value h. If x is 1 and h is 2, then x plus h is 3, right?
Okay.
So it's not fancy at all, but then this point right here would be f of x plus h. And then this point would be x plus h, comma, f of x plus h, right?
Wow. Okay. That's interesting.
Right? Makes sense though, right?
Yeah.
And I could then, let me do it in a different color. I really hate using this annotate thing, but I'll do it anyway. So now I'm going to connect these 2 points, and I'm going to say those 2 points, this makes a secant line, doesn't it? But I can easily find the slope of that line, right? It's going to be f of x plus h, f of x plus h minus f of x over x plus h minus x. Does that make sense?
I believe.
Well, the slope of a line is going to be y2 minus y1 over x2 minus x1, right?
Yeah. Okay.
So I'm going to call this x1. I lost my. I hate when that happens. I really hate this annotate tool. Okay, so right here. So if this point right here is x plus h, comma, f
of x plus h, right?
f of x plus h, yes. Then I have, this is x1, this one right here is x1, y1, and this is x2, y2, right?
You just plug it all in.
You just plug it in and you get that, don't you?
Yeah, you do x plus h minus x. Is that what it was,
It's
right?
f of x, so the y's are the f of x, right? So it's f of x plus h minus, here, let me write it again. So it's f of x plus h minus f
X.
of x over x plus h
minus x.
minus x, right?
Okay. Makes sense. Perfect.
Okay, good. And notice here, this x and this x cancel out, and I just get my difference quotient, which is f of x plus h minus f of x over h. That's where the difference quotient comes from. Is that clear? I don't have any idea why that went away. I'm really sorry. I'll put it back in a little bit, but have to put it back right now. Yeah, I'm just going to do it in black because black doesn't erase itself. Here we go. F of x plus h. So we have f of x plus h minus f of x over x plus h minus x. And here, notice the x's cancel, and I get f of x plus h minus f of x over h. So far, so good? Yes? Okay, perfect. All right, so now, what are we going to do? We want to say, but I still want the slope of the tangent line. All I have now is the slope of the secant line. So let's move this point closer. So I'm going to make this point here x plus h.
Mm-hmm.
And so now I have a point here. And now if I connect these 2 points, I'll get a line like this, still a secant line. But as I move this closer and closer, and as h gets smaller and smaller, let me see if I'm going to try it in color. As h gets smaller and smaller, I'm moving along my curve closer and closer to my other point, aren't I?
Yes.
So if I say, let's let h go to 0, then I have the slope of my tangent line, don't I? Because those 2 points are getting so close together that they're indistinguishable. And just like we said here, let's see, is this where we said it? Oh, I can't move slides until I get rid of this, the annotate tool. So does that make sense what I said here or no?
Yeah, so instead of using the other derivative tool, like the slope of another point, you use the limit because it's indecisive. It's like, you use that one.
Well, that's what a derivative is. It's the slope of the line tangent to a curve. But how do you find the slope of a line that's tangent when only one point is touching?
Use the limit as h approaches 0.
Right, so you have 2 points, and what's happening, those 2 points are getting so close together that they almost look like 1 point. The smaller h gets, like when h is 0.1, they're pretty close together. When h is 0.01, they're closer. When h is 0.001, they're even closer, right?
Yeah.
So as h goes to 0, these points are getting closer and closer together, and we're going to end up with the slope of the tangent.
Okay.
Yes? Does everybody understand that? Okay. I guess that's a yes. So here is our formula for the derivative of a function, just like I said. I'm sorry. So now we have to talk about Well, actually, let's do the next problem, and then I'll talk about something new. So here we have a problem, and it says, let f of x equal the square root of x. And I want to compute, this is a notation for the derivative. I'll show you all the different notations. This means compute the derivative. Okay, so that's A. So what I have to do is I have to say, well, if I want to compute the derivative, that's equal to this limit as h approaches 0 of f of x plus h minus f of x over h, right? And I can say f of x plus h is equal, what's f of x plus h equal to? Everybody should know the answer.
The square root of x plus h.
Exactly. Perfect.
Yay.
And then, thank you. And then f of x is equal to square root of x, right? So let's put it in. We have the limit as h approaches 0 of the square root of x plus h minus the square root of x over h. Now, how do I compute this? How do I find this limit? Because if I just plug in h, I get 0 over 0, right? So who knows? Who knows what to do here?
You can make the square root of 1/2, like the power to 1/2, and then you can.
No, that won't help me.
Right.
How would I do that? How do I find this limit?
Would you plug in a number for h that's very close to 0?
No.
Can't you just plug in the x?
No. We just did a bunch of limits like this, didn't we? Come on, guys. That was only a couple days ago.
Square
How do you
it?
compute this limit? What?
Would you square it?
Can I, so if I say 1/2, is that equal to 1/2 squared?
Could you conjugate square it?
Ah, there we go. You have to take the conjugate, remember? You have to try the conjugate, because if I just plug it in, I know it's 0 over 0. I can't reduce it. Remember, the first step was plug in h, but I get 0 over 0. The second step was see if I can simplify it, but there's nothing here I can do to simplify it, can I? So remember what I do, I'm going to try to multiply by the conjugate. What's the conjugate, Jax?
The square root of x plus h plus the square root of x.
Good. And I'm going to multiply that by the same thing, right?
Yeah, because you got to only multiply by 1.
Right. Perfect. So now, what happens in the numerator when I multiply those? What do I get?
Well, it gets stronger. It becomes x plus h minus x.
Exactly. Does everybody understand how we get that? If you don't, you should probably ask. Okay, good. So here the x cancels out with that x, and I end up with h over h times the square root of x plus h plus the square root of x, right? And I can
Yeah, but the
cancel these.
h's cancel. Yeah.
Exactly. So now I have the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. And now I just plug in h equals 0, and I get 1 over the square root of x plus the square root of x, which is equal to 1 over 2 times the square root of x, right?
Yeah.
And that is my derivative.
I love it.
Okay? So, yes.
Why, when you multiply the conjugate in the second row, how does the x, the root, cancel? So if you multiply
So
x
if
plus
I
h,
have a plus b times a minus b, what does that equal?
that would equal a squared minus b squared.
Exactly, and that's really what I have. So I have a, so a is equal to the square root of x plus h, and b is equal to the square root of x, right?
Yes.
And then so I have a minus b times a plus b, don't I?
Yes.
So that equals a squared minus b squared. So what's the square root of x plus h squared?
Square root of x plus x squared. Oh, it's just x.
No, the square root
Square
of
root.
x plus h squared.
Oh, x plus h.
That's where I got the first x plus h, and then the square root of x, the square root of x squared is equal to x. That's how I got the x.
Okay.
Yeah?
Yep. Perfect.
Okay, good. Perfect. So now that's the answer to A. Now B says find the equation of the line tangent to the graph at 4, 2. And the easiest way to do these is to use point slope, because I have point slope says y minus y1 equals m times x minus x1, right? Everybody remembers point slope form?
Yes.
Good. And I have a point, don't I? I
Yeah.
have y minus 2 is equal to m times x minus 4. Yes?
Correct.
Good. And now I know what m is. How do I know what m is?
M is your slope, isn't it?
M is my slope. How do I find my slope?
Isn't that your derivative?
It is. But the slope usually doesn't have variables in it, does it?
The slope. No, it does not.
So what can I do? You're really close, Joey. You're almost there.
I know.
Think about it for a sec.
It has we had to rationalize.
Nope. Nothing hard. There's nothing hard here. It's very simple. So I have this graph, and here's the graph of square root, let's say.
Oh.
And here is the point 4, 2. And I want to know what the slope of this line is, right?
Correct.
So, and I have everything I need. I promise you, everything I need is right here. What's the slope of that line?
Oh, put it into slope intercept form. That.
No. We don't. We still need the slope. We can't put in the slope intercept form.
Well, isn't the slope 1 over 2 root x?
Yes.
We can't
You're
have
missing one part. Does anybody know what part he's missing?
y-intercept.
Nope.
You have to put the x in.
You have to put the value for x in. So we said at this point 4, 2, so m is going to equal 1 over 2 times the square root of 4, right?
Yeah, I thought
I'm telling you, it's super simple.
Yeah.
Yeah, I wasn't going to be a hard thing. So I know the equation for the line. The equation of the line tangent to the graph at 4, 2 is y minus 2 equals 1/4 times x minus 4.
Yes, that makes sense.
That makes sense?
I didn't know. I didn't realize that was the part that we were missing.
Yeah, because we need a number. Slopes always have a value.
Yeah.
So we're going to plug in that value. Are there any questions about this?
Now, would you have to simplify where you would distribute the 1/4?
No, that's fine. This is a perfect answer.
Okay. So we can leave it in point slope.
You can leave it in point slope. This is an equation of the line. Okay? You don't have to put in the slope intercept. Sometimes slope intercept is easier. It depends on what you're using it for. Usually for derivatives, point slope is a lot easier. Okay?
Yep.
So now, here's some different notation for derivative. This one we've seen, the top one we've seen, we just say it's f prime of x. Second one, y prime. Now, I prefer these notations, but I don't know what your teacher is going to prefer. And I don't know what you're going to prefer. These are very helpful because basically this says I want to find the derivative of y with respect to x, which means I have y equals 3x plus 2, for example. That's I want to find the derivative of y, but here I have an x. What if I had y equals 3t plus 2, and I want to find the derivative? I would write dy dt. I want the derivative of y with respect to t. Does that make sense? So
Yeah.
this gives a little more information. These d over d give you a little more information about what the independent and dependent variable are. Okay? And often that's helpful. It's not going to be helpful in this class. I don't care what notation you use. We're not going to go into derivatives very, very intensely, but just to let you know what these different notations are. All right, and here's the point slope form. Actually, I could probably move that. Too far. I'm just trying to get these slides in some nice order. Okay, so now what we're going to do is talk about the derivative as a rate of change, okay? Because the derivative is a rate of change. So let me give you an example. Let's say I have, here's what we're going to do. I'm going to draw a graph, and what we're going to do is we're going to go on a trip, and we're going to call this time, and we'll do time in hours, okay? And we'll call this distance, and we'll do distance in miles, okay? And let's say I'm going on a trip to Orlando, okay? So we get on the road, and I get on the turnpike, and I start driving, and I'm driving 70 miles an hour, okay? So in 1 hour, I will have driven 70 miles. Agreed? Yes. Okay.
Okay.
Okay. And then,
Where this is going.
you know where this is going? Okay, good. And
Kind
then,
of.
okay,
Yeah.
good. And then I'm going to stop because I have to get some gas, and everybody in my car wants to go to the bathroom, and then they're hungry. So we end up having to stop. So let's say we stop for an hour. And if you ever drive with me and want to stop for an hour after we've driven for an hour, But let's just say we have to, okay? So we stop for an hour, and then we get back in the car, and I'm like not too happy because we just wasted a whole lot of time. So I'm going to get in the car. I'm going to start driving faster, right? I'm going to now drive. Yeah, this is 70 miles an hour.
Or you
this
hit
is
traffic.
0, huh?
Or you hit traffic for 5 hours.
Okay, thanks. I hit traffic, but I'm gonna just go faster now because I'm on the turnpike, and I'm gonna say now I'm gonna start going 80 miles an hour because I wasn't too happy about stopping. So now here we are, and this is 150 miles, right?
Okay.
Okay, and then let's say we get, okay, good, that was a good one. We start getting into Orlando, we start getting traffic, and so I have to slow down, and I'm slowing down to 50 miles an hour, so now I've gone 200 miles in 4 hours, and I've arrived at my destination. Okay?
Perfect.
So everybody understands this graph.
Mm-hmm.
Okay, good. So now, if I want to know what is the average rate of change, who remembers what the average rate of change is the same as?
The slope.
Exactly. So I wish I could change the color on this. I don't know why I can't.
Is this where vectors come in?
No vectors, no. You won't see vector. You'll see vectors in physics. I'm sure you'll see vectors in some of your engineering classes, and you'll see vectors in math again, probably in Calc 3. So until then, you won't see vectors. Okay, so now but I want to know the average rate of change from beginning to end, right? So what that means is I'm going to start here, and I'm going to go here, and I want the slope of that line, don't I? Say yes.
Yes.
Okay, good. So the slope of that line is going to be, well, I go from 0 to 200, so it's 200 minus 0 over 4 minus 0, right? So this is going to be, my average rate of change is 50 miles an hour. My average speed was 50 miles per hour, wasn't it? Like if you called me and you said, I'm leaving right now. Oh my God, I hate this stupid thing. So if you call, so my average rate of change is 50 miles per hour. If you called me when you left and said, okay, I'm leaving now, and you called me 4 hours later and said, okay, I got there, and I knew you were going to drive 200 miles, I don't really know what you did on the way, but I figure you were going about 50 miles an hour, right?
Yes.
Okay, so that's our average rate of change. But as you can see on our graph, we went 50 miles an hour part of the time, but we also went 70 miles an hour. We also went 0 miles an hour. We also went 80 miles an hour. So that's what's showing on my speedometer. So my speedometer is the instantaneous rate of change, isn't it? So,
yes.
So right here, I'm going my instantaneous rate of change, or my rate of change at that instance, is going to be 80 miles an hour right here, and 50 miles an hour right here, and 70 miles an hour right here, and 0 miles an hour right there. Isn't that true?
Yes.
This is the same as the derivative. The derivative gives me my instantaneous rate of change because I can draw at any one of these points, I have a tangent line, which is the slope, right?
Yes.
So, and it's what's showing on my speedometer at every point. So that's the difference between average rate of change and instantaneous rate of change. One's the derivative, one's the tangent line to that curve, one's the average rate of change, which is the secant line to the curve. Yes?
Correct.
Okay, good. Now, that means if I take the derivative of this function with respect to time, I'm going to get velocity. When I know that f of t is equal to distance. Yes?
Correct.
Does everybody understand this besides Joey? Or is Joey speaking for everyone? It's okay.
I'm just speaking.
Joey, speak for everyone.
Okay, and if anybody has a question, you'll jump in and tell me, wait, I don't understand that. Okay, perfect. So now I also have another notation. This means the derivative of the derivative. So now I can say the derivative of the distance is the velocity, and I can say that the derivative of the velocity, sorry, that's not what I wanted to say. I wanted to say let me just write it out. The derivative of the velocity which is the second derivative of the distance, which is the first derivative. No, it's not that. I don't have a whole lot of notation to help me yet. So
yeah, this is a derivative.
Yeah, we don't have a lot of notation. I only have one lecture, so I'm just trying to tie it all together so you have some idea when you walk into calculus is what everybody's talking about. Okay, so the derivative of the velocity. Does anybody know what the derivative of the velocity would be? Exactly, David. It's the acceleration. The derivative of the velocity, I'll call this v of t, is equal to acceleration. Okay? So we start off with distance, we take the derivative, we get the velocity, we take the derivative of velocity, and we get the acceleration. Everybody with me? I'll assume that's a yes. And we can see here, this is actually a really nice picture that I couldn't draw very well of this would be, for what we were talking about, this would be x, and this would be x plus h. And notice, as I move this point closer and closer to x, I'm getting closer and closer to that pink line, right? There's the blue line, which is the secant line, but then the pink line is the tangent line. Okay? Let's see what else we got. That slide. We just talked about this. Talked about this already. So it says we know that one interpretation of the derivative is the slope of the tangent line to the curve at a point. And now we have a second interpretation, which says that the derivative is the instantaneous rate of change of the original function. So the derivative of the position or of the distance is the velocity, and the derivative of the velocity is the acceleration. Okay, that's the same as the rate of change of the velocity is how fast something's accelerating, right? Let's see if I have what I have. And the difference between the average rate of change and the instantaneous rate of change is just this limit as h approaches 0. Okay?
Hold up, taking a picture of that.
Okay, no worries, no worries. I heard it.
Yeah. Computer.
All right. So that's basically how to find things. Now let's just talk about what the derivative is. We've already talked about this. Now, I'm not going to go over this. What I want to say is, where's the slide that I want? Here, let me move this slide. There's a slide here I want to go. So when is a function not differentiable at a point? Because I can not necessarily always have a curve or a function be differentiable. All polynomials are differentiable. Remember we talked about the graph of polynomials. Polynomials are smooth and continuous, right? But let's say I have a function that's not continuous at a point. I can't take the derivative at that point because I won't really know. I'll show you later. I actually have a picture. So if it's not continuous, I can't take the derivative. If it has a corner, also a cusp. So corners basically are graphs that go have a point on them. And a cusp would look something like that. So this has a corner, and this has a cusp. And neither one of these are differentiable at that point. Okay? Or if it has a vertical tangent line. I can't take the derivative at that point either. Okay? So here we have corners, right? I can't take the derivative. I can take the derivative of this function if I know what it is, but I can't say that the derivative at these points, there is none. It's undefined because, remember, the derivative is the slope of a line tangent to that curve. And if it goes slowly to that, we can figure out what it is because we can take points closer and closer. But notice here, I have the slope on this curve is basically -1, and the slope on this side is +1. And we can't go, it's not smooth. We can't get to a derivative. We can't get to the slope at that point, at that corner. Okay? Okay?
Yes.
Makes sense? All right. This one, well, here's why, but let's not worry about that. Let's say here, this is not differentiable right at where it's not continuous because I have probably two different slopes here. So what would it be at that line, at that point? It doesn't exist. Clear?
Clear.
Okay. Don't worry about that. Don't worry about that. So is the absolute value of x differentiable?
No,
Why?
because it doesn't have like a tangent to, it has a corner. So you
It has a corner, right? If I graph the absolute value of x, it's a v, and a v has a corner. We can't find the derivative of that function.
Now I have a question about that.
Yes, sir.
Oh, I know like an absolute value function. It has like it has like an inverse slope, I guess you could say. I think it's like 1 is -1, and then it's 1 on the other side.
Sure.
Like just like what's it called? Coincidentally, the average of those two slopes is 0. Is that like what?
No, you can't do that. This is not differentiable.
Okay. It's just at the corner because of the f of x.
It's not differentiable at the corner. We don't have a derivative for the absolute value of x. I can say when x is less than 0, f of x equals minus x, and I can take the derivative of that. And I can say when x is greater than 0, f of x equals positive x, but I can't, when x equals 0, there's no derivative.
Okay.
Okay?
Mhm.
Okay. And here's like the solution to it, but we're not going to go through it all. We're not going to go through that. I thought I had another problem. Let me make one up. So let's say I have the position of a particle is given by f of x equals x squared plus 2x plus 3. Okay?
Mhm.
A, I want to find the velocity. How do I find the velocity of this function?
Okay. Someone else want to speak for Joey?
Yeah, somebody else can speak. I would love that. Good, Chris. Oh, so Jax has her hand raised and everybody else has already answered. I take the derivative. The derivative of the position or distance function is the velocity. So I'd say that's equal to the limit as h approaches 0 of x plus h squared plus 2 times x plus h plus 3. That's f of x plus h, isn't it?
Yes.
And then I subtract f of x, and it's over h, right?
Yep.
So now I have to do some algebra. I get x squared plus 2xh plus 2x. I'm sorry.
Didn't you forget h squared?
Yeah, I did. Hold on. That was definitely not. Come on. Plus h squared plus 2x plus 2h plus 3 minus x squared minus 2x minus 3 over h, right? And then we can cancel this x squared with this x squared, and minus 2x with minus 2x, minus 3 with plus 3. And I end up with the limit as h approaches 0 of 2xh plus h squared plus 2h over h. Then I can factor out the h, right? And I can cancel them, and I get the limit as h approaches 0 of 2x plus h plus 2, which equals 2x plus 2, right?
Yes.
So that's the derivative, or the velocity, of that particle.
Easy.
How do I find the acceleration?
Oh, well,
Yeah,
wait.
David, you got it. I'm not gonna tell them because I'm gonna let them guess, but you got it. You're right, David. What did we say the acceleration was?
The derivative of the velocity?
The derivative of the velocity, exactly. So I can just do it again. Now I have the limit as h approaches 0 of this is my velocity, so I have 2 times x plus h plus 2, right? Minus 2x plus 2 in parentheses over h. The 2's are going to cancel. The 2x and the 2x are going to cancel. And I get the, I'm going a little bit, skipping a few steps because I don't have a lot of room. Sorry about that. Right? 2h over h, which is equal to, I can cancel these, and I get 2. So the acceleration here, this is the, so we have the acceleration is 2, and the velocity is 2x plus 2. Does that make sense to everybody?
Yes.
Any questions?
Can you go over a problem that has the A involved in it?
Do you have one?
Let me see. Not off the top. Let me see.
The A doesn't make a difference. I think you're saying something like f of 2 plus a, like, would it be, I'm not sure what the question would be. That's what I was trying to.
The question is evaluate the difference quotient for each function and the value of A. So is it like just what we pretty much did? So you have f of x cubed and then A equals 2. So you just find the derivative of.
You can find the difference in the derivative and plug in 2, or you can actually say 2 plus h, because x is 2, right? Or a is 2, minus f of 2 over, wouldn't it be over 2? It's not over 2. We want to find the limit as a approaches, well, still it's h approaches 0. Yeah, it's over h. And then you would just plug it in.
So you plug in 2 for x, and then you just
plug in 2 for x if you're given it, if you want to find it at a equals 2.
Okay.
Or you could, yeah. Is this I don't know if they give you. There's another formula you can use. So
yeah.
As x approaches a, you can say f of x plus. Is it? Oh, let me think. No. It's f of, yeah, this is it, minus f of a over x minus a. So there's a lot of different formulas for derivatives because there's a lot of different ways you can express the slope of a line, right? Here for this one, I would be saying I have this graph. This is x cubed, so let's do that, right? And now I have a point f of x, and I have a point f of a. And now this is x comma f of x, and this is a comma f of a. And I should probably have done it the opposite. It doesn't matter. So the slope is going to be the y2 minus y1 over x2 minus x1. I'll just call this point 2 and this point 1, right? And then as x approaches a, or as a approaches x, basically, what's happening is this is still getting you're still getting the slope of the tangent. Because this point is moving, well, actually, this point is moving that way for this problem, the way I wrote it. X is approaching A. But you're still going to get, this one would actually give you, I would have, like, this is actually a little bit incorrectly written the way I have it.
Yeah, I think
It
it's
should
F.
be
I
f
think
of A minus f of x, yeah.
It'll be f of A plus h minus f of A all over h.
That's another way. There's a lot of different ways to talk about the derivative is the problem.
Okay.
Because it's all the slope of a line. Do you understand? So because it's all the slope of a line, there's lots of different ways to say it. I could say f of x, I could say y, right? I can say a lot of different things. Does that make sense what I'm saying? Like if I wanted to write an equation for the slope, it would always be the slope. Like I can write the slope is equal to y2 minus y1 over x2 minus x1. Or I can write the slope is equal to f of x2 minus f of x1 over x2 minus x1, right?
Yeah.
It still means the same thing. It's just notation.
Okay.
Okay?
Mhm.
Did that answer your question, Joey?
Yeah, no, it did. It's just because it's all clarified different too. And then I just like asking the questions because I remember when I missed a live lecture, like people watch it, kind of see it. So
Yeah, no, that's good. I appreciate it. Okay, so now we have the way to determine the derivative using the limit definition, and now I'm going to give you some formulas. Now on a test, if I ask you to find the derivative using the limit definition or the definition of the derivative, I want you to do exactly what we just did, okay? If I say find the derivative, you can use this. If I don't specify how, you can use these formulas. So let me give you a couple formulas. If you have f of x, there's an f of x prime. So if I have f of x equals some variable to a power, the derivative is always equal to n x to the n minus 1. So for example, if I have f of x equals x to the 5th, then f prime of x equals 5x to the 4th. Okay? Is that clear?
Yeah.
Okay. If I have the sine of x, the derivative is the cosine of x. If I have the cosine of x, the derivative is the negative sine of x. Okay? I don't know if we're going to use this, but this is a pretty nice, easy one. The derivative of e to the x is e to the x. Okay? And the derivative of the natural log of x is 1 over x. So these are, you won't, in calculus you'll get a lot more, but in this class that's it. That's all I expect you to know. Okay? And then there's just one more thing. If I have a constant times a function, the derivative is the constant times the derivative of the function, which, for example, is if I have f of x equals 5x to the 3rd power, the derivative, so now 5 is my constant, so I just move my constant, and then I take the derivative of the function, which is 3x squared. So this becomes 15x squared. Does that make sense?
Yeah, where did we get the 3? Wait, yeah, where did we get?
Because the derivative, so the derivative of x to the 3rd, let's look at it. It's right here. This is my function, x to some variable, right? I mean, x to some power. And the power is, n is 3. So the derivative is n times x to the 3 minus 1.
Which is, okay.
Basically, you just bring this forward. A little bit like logs, but not the same, not for the same reason.
Okay.
Okay?
Yep.
So does this make sense now?
Yeah.
Okay. Is there any other questions? Okay, I think that takes care of everything you need. Here, let me stop sharing. All right, guys, so is there any questions anybody has about anything? Right, so I'm going to stop.
I have a question about the LA.
Okay, I'm going to leave this running, I'm going to leave the recording going in case it's something other people might be curious about. What is it?
Is there a typo on 2A? Because there's no equal sign.
On 2A, what are you talking about?
The LA worksheet.
On the LA worksheet, I'd have to look. Let me look. Hold on. Hold on. LA worksheet 2A. 2A. Find the derivative of the function. Oh, I didn't tell you that derivative. So thank you, Jack. I missed one. So the derivative, let's see if I can write on this screen. What? Nope. Okay, hold on. Let me get another whiteboard, just so I can write it. So the derivative so if I have a function that's a constant.
Okay, so there's an implied equal sign on this one because it's not on there.
Oh, it isn't on there?
No, it just says f of x minus 9.
It says equals 9 on my thing.
Oh, I don't know why it printed out weird on mine. Okay.
When I look at it, it says equals, unless I'm seeing double. But that's good anyway, because I forgot to tell you what the derivative of a constant is. So hold on, let me get back. The derivative of a constant is 0.
Oh, that's good.
It should be kind of clear, because if you think about it, hold on, let me show you. Let's say I have y equals 4. It looks like that, right?
Oh,
it's a horizontal line.
Yeah.
What's the slope of a horizontal line?
0.
There you go. Okay. So I know you asked me for a different reason, Jax, but thank you for reminding me. I didn't give you one. And that's that. So, any other questions? Thanks, Jax. But it does say equal, I think.
Okay, thank you.
Okay. Okay, so now I'm going to, so how many of you guys are going to stay around for the LA work, for the LA time? So if you're not going to, have a good one. I'll see you later. Thanks for coming.
Bye, Ms. Greenberg. Have a good day.
You too. Bye, Joe.